The mystery of the moon's formation is one that has captivated scientists for as long as human beings have been able to contemplate the stars. Raw fragments of material for the formation of the moon were floating in space. This theory is considered to be the Earth and iron ore. Things that material from both sources and isotopic signatures hint that the two objects were formed from the same material. The mystery of the moon's formation.
In its orbit. It's the stretchiest planet that we've confirmed the stratus of, lead author Ma Zhong, an exoplanet scientist at the
Their observations revealed that just as unusual as the planet's lemon shape is the composition of its atmosphere.
Position. This is PSR J23222650b. What makes it peculiar is its shape and composition.
We're witnessing an entirely new type of object that...
Imagine a faint star hauling a cyan super Neptune, close on the blue giant, racing through starlight. Its orbit slices the star field at unbelievable speed. The whole system blurs, surging past background stars. They barrel through the dense Milky Way bulge. A bold trajectory shows escape from the galactic center. The dim host star clings to its rushing planet. Gravity lenses light, warping a background star. See the partial Einstein ring curve into view. A warm, faint star, orbited by a super Neptune. Distance sits between Venus and Earth, roughly that scale. Velocity is extreme. Hundreds of kilometers each second. They near galactic escape speed toward the halo. Soon, they could cruise beyond the Milky Way. First hints appeared in archival data back in 2011. Later observations confirmed the strange speeding system. Tidal forces squeeze the planet as it orbits. It's the first known planet of a hypervelocity star. Finally, the pair streaks into the deep empty dark. Imagine a... Why do 100% of space fans freak out when a new telescope arrives? Because it's not just bigger, it's a game changer. This is the Nancy Grace Roman Space Telescope, finished early and hungry for the cosmos. Launch could happen as soon as September 2026. Construction wrapped on November 25, 2025 at Goddard. Roman packs a 300-megapixel wide-field camera. It sees 100 times more sky than Hubble. With Hubble-like sharpness, in a 5-year run it could find 100,000 plus exoplanets, map billions of galaxies, probing dark matter, probing dark energy. Tests are next. Shipping is next. Falcon Heavy launch window in fall 2026 to mid-2027. Big science, big pictures, maybe big discoveries. Stay
Exposing the magic in the night sky. 6 planets, 1 perfect lineup. February 28th is your date with the universe. Here's how to catch this rare show. On February 28th, right after sunset, grab your binoculars and head outside. Look low on the western horizon. Mercury and Jupiter kick things off, shining close together. Next up, catch Venus, glowing a little higher. Mars joins the party with its signature red hue, while Saturn and Neptune form the final pair. A bit fainter, but totally worth the hunt. The best viewing time? About 30 minutes after sunset, when the sky's dark but the planets haven't dipped too low. Find a spot with a clear view west and away from city lights. Even just your eyes can spot most of them, but binoculars will help with the dim ones. Mark your calendar. This 6-planet alignment won't happen again for years. Don't miss your chance to see the solar system in action.
You need to see this. I just found this insane Memos article. This tiny moon, known for its crater, has a secret ocean beneath its icy shell. How is that even possible? This article's full of wild facts, and check out these images. They even had this crazy abstract pink cosmic marble version.
In the vastness of space, constellations act as our celestial compass, etched against the fabric of the night sky. Each one carries a unique story, often steeped in mythology and folklore. Take Orion, the hunter. His belt may be famous, but it's his shoulder, Betelgeuse, that truly shines, one of the brightest stars in the night sky. Then there's Canis Major, the great dog. It's home to Sirius, the brightest star of all, outshining every other star we can see from Earth. Next up, Lyra, the small but mighty constellation. Its brightest star, Vega, helps form the Summer Triangle, a familiar sight for stargazers. Remember, the night sky is a storybook. Each constellation, each star is a piece of that tale. So, look up and let the cosmos unfold its mysteries.
Why do 90% of new exoplanets surprise astronomers? Because space is full of wild secrets. Like this, an ocean planet just discovered 100 light-years from Earth. Astronomers have spotted a planet called Toei 1452b, and get this, it's probably one giant water world. No land, just endless waves stretching for thousands of kilometers. This planet orbits a small, cool star in the Draco constellation. It's a little bigger than Earth, but way wetter, possibly with oceans deeper than anything here at home. Imagine the creatures that could live there, or the storms that might rage across a planet-wide sea. How do we know it's wet? Scientists measured its size and mass, and it doesn't fit a rocky world. The numbers scream, water, planet. And here's the coolest part. With telescopes like James Webb, we might soon peek at its atmosphere and look for signs of life. So next time you look up, remember, our universe is packed with strange and amazing worlds, just waiting to be discovered. What's something people don't know about Venus? There might be giant hollow spaces hiding just below its surface. Yeah, you heard that right. On Venus. Venus is one of the hottest planets in our solar system. Its surface can melt metal, but researchers are buzzing about strange signals picked up by radar. These hints suggest there could be hollow structures like caves or even tunnels, deep under all those clouds. How could they form? Well, Venus has tons of volcanoes, and just like on Earth, volcanic lava can carve out massive underground tubes as it flows. If that's happening on Venus, these hollow spots could be huge, big enough to fit entire cities. So why does this matter? Scientists hope these hollows could protect future explorers from deadly Venus heat and toxic clouds. It's still a theory, but every new discovery brings us closer to unlocking Venus's secrets. What do you think they'll find next? Hit like if you love space mysteries. This is why you need to know about asteroid Apophis. It's hurtling toward Earth and could be a real threat, and by 2027, scientists will finally have an answer. Meet Apophis, an asteroid the size of the Empire State Building cruising through space at 67,000 miles per hour. In 2029, it'll fly closer to Earth than some satellites, just 19,000 miles away. That's way too close for comfort. Back in 2004, scientists worried Apophis might actually hit us. Now, they say the odds are super low, but not zero. Here's the wild part. By 2027, after tracking Apophis for years, researchers will finally know for sure if we're safe or not. So, what happens if it does hit? Think, a blast bigger than 1,000,000 tons of TNT. But don't panic just yet. Advanced telescopes and space missions are on the job watching Apophis every step of the way. Want to know the final answer? Stick around, because science is on the case, and the countdown to 2029 has already begun. You need to watch this if you've ever dreamed about meeting aliens, because finding life out there is just the beginning of the chaos. First, scientists can't just tweet, "Hey, we found aliens." They double, triple check the evidence. Nobody wants a false alarm. Next, governments step in. Who tells the world? When? Is it safe? Some people might panic, others might celebrate, and a few would say, "I told you so." Experts have to make sure the news is clear and accurate, so nobody freaks out or spreads wild rumors. Plus, if the aliens are sending signals, how do we even understand them? It's like getting a text in a language no one on Earth speaks. Communicating with aliens isn't just about saying hi, it's about making sure the whole planet gets the message and reacts calmly. So next time you look up at the stars, remember, the real challenge might not be finding aliens, but telling the world we did. You need to
Hadar, or Beta Centauri, is a prominent blue-white giant star. It's the 11th brightest star in the night sky. Located about 390 light-years away in the constellation Centaurus. Hadar is a triple star system consisting of massive, evolving blue stars. These massive stars are key to understanding stellar evolution. Hadar serves as a southern pointer star to the Southern Cross. Join us as we explore the mysteries of the cosmos and the stars. Spica is the brightest star in the constellation Virgo, known for its vibrant blue color. It is located approximately 250 light-years away from Earth, making it a fascinating object of study. Spica is actually a binary star system, consisting of two stars orbiting each other. It shines with a brightness that is about 2,000 times that of our Sun, showcasing its massive size. Spica plays a significant role in navigation and astronomy, being prominent in the night sky.
Enjoy the view. It's all yours.
Spica is the
You need to hear this if you love space trivia. Pollux, one of Gemini's twins, is full of surprises. Buckle up. Pollux sits about 34 light-years away. It shines at magnitude 114. That's bright. It's a K-Butter-tree orange giant. It used to be a normal star. It is swollen up after burning through its core hydrogen. Funny fact, it's officially Beta Geminorum. It's brighter than Castor. So much for alphabetical order. Pollux also plays host to an exoplanet, Pollux B. Pollux B is a gas giant a couple times Jupiter's mass. It orbits every 590 days. Scientists spotted it by the wobble in Pollux's light. Radial velocity detective work. Size, think nearly 10 times the sun's radius, almost twice the sun's mass. Big and mellow. So next time you spot Gemini, point to the orange one. That's Pollux. Giant, planetary, full of cosmic personality. Researcher team. Quick star fact over. Like for more.
Exploring the vastness of the universe. Millions of galaxies, each with its unique charm. From spiral to elliptical forms, watch them unfold. Enigmatic black holes lurk within. Galaxies collide, creating stunning cosmic events. Each galaxy has a story waiting to be uncovered. What secrets do they hold within? The universe is a canvas painted with galaxies. Exploring the vastness.
In 1977, astronomers detected a strong signal from space, famously dubbed the WOW signal. For decades, scientists pondered its source without a definitive answer. Recently, researchers believe they have traced the signal to a comet. This finding may reshape our understanding of extraterrestrial signals. But is it truly an alien signal or just a natural phenomenon? The WOW signal opened doors to future research and exploration of the cosmos. Stay tuned for more modern mysteries as we unveil the universe's secrets.
Moon, gone. You wake, nothing. Freaky. Tides shrink. Coasts go wild. Nights darker. Migrations scramble. Sleep skews. Tilt wobbles. Seasons glitch. Climate warps. Sat-nav freaks. Myths, gone. We adapt. Tougher coasts, maybe fake moons. Panic now. Reinvent later. Moon.
Everyone's freaking out about February.
Introducing KOINTREAU-1, a newly discovered planet. This planet was confirmed in 2026 during a survey. It humorously shares a name with the famous liqueur. How unique is that for a celestial body? Explore with us as we delve into the wonders of KOINTREAU-1. What awaits us on this whimsical planet? Stay tuned as we uncover the secrets of KOINTREAU-1. Subscribe for more cosmic discoveries.
If you're a space enthusiast, this is the planet you need to know. LHS 1140b could be our best shot at finding another Earth. Let's dive in. Orbiting a quiet red dwarf star, LHS 1140b sits just 49 light-years away. Pretty close in galactic terms. This rocky world is almost 7 times heavier than Earth and nearly 30% bigger. Scientists think it's just the right distance from its star, which means it could have liquid water, maybe even vast oceans. But here's the real twist. LHS 1140b might be a water world with a thick atmosphere that could protect life. Imagine swimming on another planet. Astronomers are using superpowered telescopes to peek at its atmosphere and hunt for clues, like water vapor or signs of life. So is LHS 1140bi the next Earth? We don't know yet, but the search is on. And discoveries like this keep the adventure of space alive. Hit like if you think we'll find alien oceans soon.
You need to watch this if you've ever wondered how long our solar system can last. Think 10,000 years is a long time. Let's see what might actually change. In 10,000 years, Earth will have spun around the sun 10,000 more times. But guess what? the planets will still be here. Mercury, Venus, Mars, and the rest, still orbiting our star. Scientists say the sun won't run out of fuel or explode for billions of years. So, don't worry, no supernovas yet. But there will be changes. Earth's axis will wobble, shifting our seasons and maybe even the North Star. Some moons might drift farther away, and a few comets could pass by or crash into planets. Could humans still be around? Maybe, maybe not. But the solar system? It's built to last, at least for now. So, in 10,000 years, the solar system is still spinning, still shining, and still full of mysteries. The universe plays the long game. Are you ready to keep wondering?
Hollywood has the Walk of Fame. Space has a 128 Tom Hanks. Let's blast off. So what's the deal with 128 Tom Hanks? This asteroid was discovered in 1996, right as Tom Hanks was busy starring in epic films like Apollo 13. Coincidence? I think not. Orbiting the Sun between Mars and Jupiter, 128 Tom Hanks is part of the main asteroid belt. It's not huge. You could run across it faster than you could run across a football field. But hey, it's still cooler than anything in your backyard. Why Tom Hanks? He's famous for his love of space movies, especially playing an astronaut. So the scientists thought, let's put his name up with the stars. Literally. So next time you look up at the night sky, remember, somewhere out there, Tom Hanks is rocking a steady orbit. Space has never been this star-studded. Don't forget to like and subscribe for more cosmic fun. After all, the universe is full of awesome surprises.
This is why you need to know about the universe's most dangerous stars, because they could wipe out life as we know it. Let's dive into the wildest threats in space. First up, meet the supernova, a star's explosive grand finale. When it blows, it releases as much energy in seconds as our sun does in its entire life. Too close and your planet is toast. But wait, there's more. Magnetars. These are neutron stars with magnetic fields so intense, they'd erase every credit card on Earth from thousands of miles away. Talk about cosmic chaos. And don't forget gamma ray bursts. These are the universe's biggest lasers, firing deadly rays across galaxies. If one aimed at Earth, it could strip away our atmosphere in seconds. So next time you look up at the stars, remember, some of them are beautiful, but others are cosmic ticking time bombs. Stay curious and keep looking up.
Why are there not more people talking about the Eye Nebula? It literally looks like a giant eye floating in space. Seriously, is the universe staring back at us? So, what is the Eye Nebula? Officially, it's called the Helix Nebula, a massive cloud of gas and dust about 700 light-years away. But here's the wild part. From Earth, it looks just like a human eye. That pupil in the center? It's actually the core of a dying star, shedding its outer layers. The colorful rings are glowing gases lit up by ultraviolet light. And because we're looking almost straight down the center, it appears to follow us no matter where you move. So next time you gaze at the night sky, remember, maybe the universe really is keeping an eye on you. Hit like if space mysteries give you goosebumps.
Hey space fans! Did you know our solar neighborhood just got a whole lot more interesting? Scientists spotted a super quiet star, and it could be the key to finding life beyond Earth. Most stars are noisy and wild. They blast out flares and radiation that can fry any nearby planets. But this one? It's calm. Super quiet. That's a huge deal, because calm stars give planets a better shot at having water, and, maybe, life. Astronomers are excited because this quiet star is pretty close, just a few light-years away. If it has planets, they're not getting zapped by deadly space weather. That means life, at least the kind we know, could actually survive there. So keep your eyes on the stars, because this peaceful neighbor might just be our best chance at finding life beyond Earth. How cool is that? Hit like if you think we'll find alien life soon. Like if you think we'll find alien life soon. Like if you think we'll find alien life soon. Like if you think we'll find alien life soon.
Imagine gazing up at the night sky, a vast, dark canvas dotted with stars, each one a tiny beacon shining across unimaginable distances. The universe stretches out above us, mysterious and endless, inviting us to wonder what secrets it holds. Each star could be a sun, with its own family of planets, perhaps even worlds like our own, orbiting in the darkness. The possibilities are as endless as the stars themselves. But what if we could look beyond, deep into the universe's furthest reaches, farther than our eyes could ever see unaided? What wonders might we discover out there, hidden in the depths of space? Telescopes are our cosmic eyes, letting us see the invisible and understand the immense. They transform faint glimmers into breathtaking images and reveal secrets that would otherwise remain forever hidden. For centuries, we've used lenses from mountaintops, peering through Earth's atmosphere. But to truly see clearly, to escape the blur of our own sky, we had to send our eyes into space itself. Space telescopes capture ancient light that's traveled billions of years, carrying stories from the dawn of time. Each photon is a messenger from the past, revealing the universe's history in every image. Looking deep into space is like reading a cosmic history book. We see galaxies as they were eons ago, frozen in time, their light only now reaching us after a journey across the cosmos. This journey is fundamentally human. We're explorers at heart, driven by curiosity and a desire to know what lies beyond the next horizon, always reaching for the unknown. Space is our final frontier, and telescopes are our ships, carrying our vision farther than we could ever travel ourselves. With them, we ask the biggest questions. Are we alone in this vast universe? Could there be other life, watching their own skies? How did it all begin? What forces shaped the cosmos, and where do we fit in this grand story? The answers are out there, waiting in the faint light of distant stars, whispering across the ages for us to discover. Now, with powerful new telescopes and the passion of discovery, we're equipped to find them, and to unlock the mysteries of our universe. For more than 30 years, the Hubble Space Telescope has served as our legendary window to the cosmos, opening up the universe in ways we never thought possible. Launched in 1990, Hubble orbits high above Earth's atmosphere, giving us a crystal-clear view of the universe, free from the blurring effects of air and weather. This unique vantage point allows Hubble to capture details invisible from the ground. It transformed our understanding of the cosmos, turning scientific theories into breathtaking images, and revealing the true beauty and complexity of space. Hubble's powerful zoom lets it focus on tiny, seemingly empty patches of sky, revealing thousands of galaxies where we once saw only darkness. Each image is a window into the distant past. Its deep-field images prove the universe is far more crowded and vast than we ever imagined, showing us billions of galaxies stretching across unimaginable distances. Hubble helped pinpoint the universe's age, revealed the existence of supermassive black holes at the centers of galaxies, and watched stars being born in stellar nurseries and dying in spectacular supernova explosions. Its images, like the pillars of creation, have become cultural icons, art created by nature and captured by human ingenuity, inspiring generations of scientists, artists, and dreamers. Hubble connects us emotionally to the cosmos, making the vastness of space feel closer and more personal, sparking wonder in people of all ages. It's made astronomers of us all, inviting everyone to marvel at existence and to ask new questions about our place in the universe. Hubble's legacy is both scientific and inspirational, fueling discoveries and igniting curiosity that will last for generations to come. It truly brought the universe down to Earth, forever changing how we see the stars and ourselves. Enter Euclid, the European Space Agency's cosmic mapmaker, launched in 2023. Unlike Hubble's close-ups, Euclid surveys vast swaths of the sky, mapping billions of galaxies. Its mission uncovered the mysteries of dark matter and dark energy, which make up 95% of the universe. Think of Hubble as a biologist studying a single tree, while Euclid is a cartographer mapping the entire forest. Euclid creates a 3D map of the universe, plotting galaxies and tracing the invisible footprints of dark matter. By measuring how light from distant galaxies is bent by gravity, Euclid reveals where dark matter hides. It also tracks how the universe's expansion has changed, offering clues about dark energy. Is dark energy constant, or does it evolve? Euclid aims to find out. It's not just about seeing light, it's about understanding the darkness that shapes everything. Euclid is our new detective in the cosmic unknown. Hubble and Euclid are both space telescopes, but they see the universe in different ways. Hubble is like a telephoto lens, narrow, deep, and detailed, perfect for close-ups of galaxies and stars. Euclid is the wide-angle lens, capturing huge swaths of sky at once, sacrificing detail for scale. Hubble's strength is in-depth portraits. Euclid's is panoramic mapping. Hubble sees mainly invisible and ultraviolet light, revealing cosmic beauty. Euclid's power lies in the near-infrared, essential for seeing distant redshifted galaxies and peering through cosmic dust. One is an artist, the other a surveyor. They're not competitors, they're partners. Together, their complementary views give us a fuller, richer understanding of the cosmos. It's teamwork at the grandest scale. The real magic happens when Hubble and Euclid work together. Euclid, the cosmic scout, scans the sky and finds rare or unusual objects, colliding galaxies, distant quasars, or odd dark matter regions. It flags these targets, then Hubble zooms in for a detailed investigation. Imagine searching for a unique shell on a vast beach. Euclid is the drone spotting it. Hubble is the hand picking it up. This synergy makes the most of both telescopes. Euclid's broad surveys guide Hubble's precious time to the most intriguing discoveries. Hubble's close-ups reveal secrets that Euclid's wide view can't. This partnership combines the big picture with crucial details. Together, they help us tackle the mysteries of dark matter and dark energy with unprecedented certainty. It's a model of scientific teamwork, maximizing discovery. The universe yields its secrets best when we look together. The universe is teeming with galaxies. Hubble's deep images reveal trillions, each a city of stars. Galaxies come in spirals, ellipticals, and irregular shapes, often colliding and merging over cosmic time. Hubble's portraits show us how galaxies evolve, capturing dramatic collisions and starbirths. Euclid adds a new dimension, mapping how galaxies are arranged in the cosmic web, a vast network of filaments and clusters. Galaxies aren't scattered randomly. They trace this web, shaped by dark matter's gravity. By mapping the web in 3D, Euclid tests our theories about the universe's structure. The cosmic web's shape depends on the tug-of-war between dark matter and dark energy. By tracking the web's growth over time, Euclid reveals how these forces have shaped the cosmos. This turns abstract theories into mapped reality. Together, Hubble and Euclid show us not just what's out there, but how it all fits together. The universe's secrets are coming into focus. The cosmic web is the universe's grand architecture, a vast interconnected network of filaments, clusters, and immense empty voids stretching across billions of light years. This structure is the largest known in the cosmos, weaving together everything we see in the night sky and much that we cannot. Imagine a spider's web on a cosmic scale. Galaxies are strung along the delicate threads, while the spaces between are vast, almost unimaginable voids. These filaments connect clusters of galaxies, forming a pattern that echoes nature's own designs. Our own Milky Way sits on the edge of a supercluster, just one small part of this intricate and beautiful structure. We are connected to countless other galaxies through these cosmic threads. In the early universe, matter was nearly smooth and evenly spread, but gravity slowly pulled denser regions together over time, forming the filaments and clusters we see today. This process took billions of years, shaping the universe's skeleton. Dark matter's gravity acts as the invisible scaffolding, shaping the web and holding galaxies in place. Though we can't see dark matter directly, its influence is everywhere. Visible galaxies trace this hidden structure, like fairy lights strung along a wire, revealing the underlying pattern of the universe. The Euclid mission is set to map this web in unprecedented detail, tracing the positions of billions of galaxies and uncovering the universe's hidden framework. Its 3D map will reveal how the cosmic web has evolved over billions of years, showing us how galaxies and clusters have shifted and grown. By observing how this structure changes, we learn about the ongoing battle between gravity, which pulls matter together, and dark energy, which drives the universe's expansion apart. This is our best look yet at the powerful forces shaping the universe's fate, helping us understand where we came from and where we're headed. The cosmic web is the universe's blueprint, finally revealed in all its complexity and wonder, a map of the cosmos written across the stars. The universe's biggest mysteries are invisible: dark matter and dark energy. Galaxies rotate too fast for visible matter alone. Something unseen, dark matter, provides the extra gravity. Dark matter doesn't shine or reflect light. It's detected only by its gravitational pull. Euclid maps dark matter using weak gravitational lensing, measuring tiny distortions in billions of galaxies' shapes. This reveals the hidden web of dark matter across the cosmos. But there's more. The universe's expansion is accelerating, driven by dark energy. Dark energy makes up about 70% of the cosmos, yet we know almost nothing about it. Euclid will track how cosmic expansion has changed, testing if dark energy is constant or evolving. If it changes, it could point to new physics beyond our current understanding. Euclid's mission is to illuminate the 95% of the universe that remains dark. We're on the verge of a new chapter in cosmic discovery. The darkness is finally coming into view. Why do we explore the cosmos? To understand who we are and where we come from. The elements in our bodies were forged in ancient stars. We are made of stardust. Studying the universe is studying our own origins. Telescopes like Hubble and Euclid do more than answer scientific questions. They inspire us. Their images spark curiosity, foster unity, and put our place in perspective. Building these observatories drives innovation, pushing technology that benefits life on Earth. The quest to explore the universe fuels human progress. Looking up is a deeply human act, satisfying our curiosity and drive to explore. Now, we have the tools to find answers to age-old questions. Hubble and Euclid are our eyes in the cosmos, monuments to our curiosity. They remind us that the universe is wondrous, beautiful, and knowable, and that seeking knowledge is our noblest journey.
Astronomers have made a groundbreaking discovery. They spotted a galaxy predominantly composed of dark matter. This discovery challenges our understanding of the universe. The galaxy's formation offers new clues about cosmic evolution. Astronomers continue to investigate this enigma. What does this mean for our understanding of the universe? The quest for knowledge about dark matter continues.
Venus, our brilliant neighbor, has long been shrouded in mystery. For centuries it was called Earth's twin. Similar in size, mass, and rocky composition. Scientists once imagined Venus as a world of oceans and jungles, maybe even life. But its thick, yellow clouds hid everything beneath, fueling wild speculation. No telescope could pierce the veil. Only robotic probes could reveal the truth. The dream of a second Earth next door inspired generations of astronomers and storytellers. The dawn of the space age finally gave us the tools to investigate. Rockets and spacecraft were built to cross the void and answer the question, what lies beneath Venus's clouds? Venus became the first planet targeted by interplanetary probes. The quest to unveil Venus would push technology to its limits. What we found was not a paradise, but a world more extreme than anyone had imagined. The journey to understand Venus was just beginning. Its mysteries would challenge our science and imagination. The story of Venus is a story of curiosity, ambition, and the drive to explore. And it all started with a single, shining point in our sky. The 1960s saw the US and Soviet Union locked in a fierce space race. Venus, our closest planetary neighbor, became a key prize in this cosmic rivalry. The Soviets launched a relentless series of Venera probes, determined to reach Venus first. The US responded with nimble Mariner flybys, gathering data from afar. Each side pushed the other to new heights, accelerating the pace of discovery. Failures were frequent, probes lost, rockets exploded, but every attempt taught us more. The competition drove rapid advances in engineering and science. Venus became a proving ground for new technology and bold ideas. The race was more than politics. It was a quest to answer fundamental questions about our solar system. This rivalry laid the foundation for everything we know about Venus today. It was a story of persistence, ingenuity, and the relentless pursuit of knowledge. The race to Venus changed the course of planetary exploration, and it set the stage for one of space history's greatest triumphs. The Soviet Venera program was a saga of ambition and resilience. Early missions failed, but Soviet engineers learned and adapted. In 1967, Venera 4 became the first probe to enter another planet's atmosphere, revealing Venus's crushing carbon dioxide air. The dream of a tropical Venus faded. Reality was far harsher. In 1970, Venera 7 survived the descent and transmitted data from the surface, the first time a human-made object had landed on another planet. The Soviets had achieved the impossible. Later missions, like Venera 9 and 10, sent back the first images from another world. A rocky, desolate landscape under an orange sky. Venera 13 and 14 delivered color photos and soil analysis, pushing the limits of technology. Each mission revealed more of Venus's alien nature. The Venera program stands as a triumph of engineering and determination. It almost single-handedly unveiled the true face of Venus. These achievements remain a crowning moment in the history of space exploration. The Soviets proved that even the most hostile worlds could be reached. Their legacy endures in every planetary mission that followed. Venus was no longer a mystery. It was a world transformed by human curiosity. And it all began with the relentless pursuit of a dream. Why is Venus so hard to explore? Its environment is brutal. Surface temperatures soar above 460 degrees C, hot enough to melt lead. The pressure is 90 times Earth's, like being a kilometer underwater. Early probes were crushed or cooked before reaching the ground. The air is toxic carbon dioxide, and the clouds rain sulfuric acid. Surviving on Venus requires a lander that's a refrigerator, submarine, and acid-proof tank all at once. Even the best probes lasted only a couple of hours. The Venera program's success was a feat of engineering against impossible odds. Venus remains the ultimate test for planetary explorers. The missions to Venus shattered the myth of a gentle twin. Instead, they revealed a world transformed by a runaway greenhouse effect. Venus became a cautionary tale, a warning of how a planet can go wrong. American missions mapped the surface, while Soviet landers gave us ground truth. Together, they showed a world of volcanoes, plains, and alien geology. Studying Venus helps us understand climate change on Earth. It's a laboratory for the greenhouse effect, teaching us about planetary fragility. The story of Venus is a story of human curiosity and technological daring. New missions are planned, seeking answers about its past and its lost oceans. By exploring Venus, we learn not just about another world, but about the fate of our own.